Hi everybody, let's talk about research report number 4. Go ahead and click on project info and then scroll down until you see research report number 4. You'll see that for this project, you're going to collect data on two different variables, a predictor variable and a criterion variable. And then you're going to compute a correlational analysis and a regression analysis. Let's click on the instructions and find out what we need to do in more detail. Here are the instructions. Let's scroll down just a little bit. For this project, you or your group will collect data to determine if there's a relationship between two quantitative variables. For example, your group might want to investigate if there's a relationship between the number of hours students study per week and their corresponding college GPA. Those will be the two variables that I use in this example. The research question in this particular case would be, is there a relationship between the number of hours a student studies per week and his or her GPA? If I were to ask that question in terms of predictive value, then the research question would be, does the number of hours a student studies per week predict his or her college GPA? For this example, the hours of study would serve as the predictor variable, and college GPA would serve as the criterion variable. So in other words, we're using the hours that a student studies to try to predict the student's college GPA. Just like I did with my two variables, you want to be sure that you select two variables that are quantitative and are continuous in nature and are measured on an interval or ratio scale. All right, let's scroll down a little bit more and find out what we need to do specifically. There are 8 different sections to this research report. Be sure that you number each section and letter each subsection so that you can determine that you have covered all of your bases and so that I can quickly find each section in your report. Just like in research report number 1, number 2, and number 3, in section 1, you're going to write a basic introduction. So be sure that you provide sufficient detail in each one of those subsections. In section 2, you're just going to identify which is your predictor variable and which is your criterion variable. That should be pretty straightforward. Then in section 3, I want you to state your research question in those two ways that I used previously. So one is in terms of the relationship between the two variables. So in my particular case, I was trying to determine, is there a relationship between study hours and college GPA? In terms of how well one variable predicts the other, I can rephrase that question to ask, how well does a student's study hours predict that student's college GPA? All right, let's scroll down a little bit and talk a little bit more about the fun parts, the parts that use SPSS. That's what we want to focus on in this video. So I'm going to scroll down. I can see here in section 4, I'm being asked to conduct a two-tailed correlational analysis using SPSS. For example, in section 4C, it says, using SPSS, conduct a correlational analysis. Include the SPSS output in your report. I'll remind you how to do that. From SPSS, also include the means and standard deviations for each variable. That will be easy. Based on your SPSS output, evaluate your null hypothesis and interpret your findings. You should be able to do that by now. In section 5, using SPSS, we need to perform a regression analysis. We're going to be able to do the correlational analysis and the regression analysis all in one shot. Include the SPSS output in your report. Again, I'll remind you how to do that. What are the values of the slope and the y-intercept? We will have that in our SPSS output. What is the value of the standard error of the estimate? That also will be in our SPSS output. And from that output, we will be able to write the complete regression equation. In section 6, it says using SPSS, what is the effect size based on computing R squared? We will have that in our SPSS output. And then in section 7, we need to create a scatter plot where we will plot our two variables, our predictor variable and our criterion variable. And then we will show within that plot the regression line. That will require a separate SPSS analysis. I'll show you exactly how to do it. So let's go ahead and take a look at SPSS. Here we are in SPSS. I already have my data file created. I'll just really quickly remind you how to do that. You've already created a few SPSS data files, so you should know how to do that by now. I'm in data view. I'm going to go ahead and click on variable view. Remember, you will want to create one entry for your predictor variable and then one entry for your criterion variable. So you will have two different variables. Remember, most of the basic default settings are fine with us. We have numeric data. 8.2 usually works pretty well. You can stick in labels for each variable because remember, when you do that, your output will be labeled. So everything will be easy to read. In this situation, you shouldn't need value labels. And if you want, you can go ahead and list your measurement scale. Remember, for this project, you should have data that's measured on an interval or ratio level scale. So for both variables, you should select scale. Once you do those basic things to set up your data file, you can then go ahead and click on data view and then enter your data. You should have two pieces of data for each person. So for example, person number 1 studies 5 hours per week and has a college GPA of 1.5. My second person studied for 6 hours per week and had a college GPA of 2.10. So we're collecting data for two different variables from each person. All right, that brings us up to speed with our SPSS data file. Let's go ahead and run some analyses. Here I am back at the instructions just to remind us what we need to do. I need to do a correlational analysis, and I also need the means and the standard deviations for each variable, and then I also need to run a regression analysis. We should be able to do that within one shot. So let's go back to SPSS. Remember, when you need to run an analysis, the best place to look is the Analyze menu. Most things that you're going to need are going to be found right there. Let's move down this list a little bit, past comparing means, past correlate, and all the way to regression. And what we want to do is a simple linear regression. So click on linear. In order to do this regression, SPSS wants to know what's our independent variable and what's our dependent variable. And this is one of those situations where I wish SPSS used different terminology. In this particular situation, we have a predictor variable and a criterion variable. Those would have been better terms to use. Our predictor variable will be our independent variable, and our criterion variable will be our dependent variable. So the predictor variable that I'm using is study hours per week. I'm trying to determine if the number of study hours per week will predict the person's GPA. So study hours per week, I'm going to click on that and move that over to the independent variable section. And then college GPA, I'm going to click on that and move that to the dependent variable section. That is my criterion variable. All right, that's a good start. Let's go ahead and click on statistics to see what the different options are. The default options that are already checked are options that we want. The only thing that we want to add is descriptives. So now the output will show us the basic descriptive statistics, meaning means and standard deviations for each variable. We need that, so we're going to check that off. Go ahead now and click on continue. Let's go ahead and click on plots. We know that we need a scatter plot, but the scatter plot that we need that's going to show the regression line, we're not going to get from this option right here. So just go ahead and cancel out of it. Go ahead and click on save. We don't have to actually save the unstandardized predicted values, but we're going to do it anyway. I'm going to show you that this is going to provide you with a way of checking your work for something that you need to do a little bit later on in the report. So click on predicted values unstandardized, and then go ahead and click on continue. All right, that should be everything that we need for now, so go ahead and click on OK. All right, just like always, when we run an analysis, our SPSS output window opens up to show us the results. Go ahead and scroll all the way to the top. Right here is the SPSS code that is used to run the regression analysis. That's just really in my way at this point. So I clicked on it, and I'm going to hit my delete key to delete it. Let's take a minute to delete a few other things that we're not going to need for research report number 4. They're just going to be in our way. So for example, scroll down a little bit, you will see an ANOVA table. We're not going to need that for research report number 4. So go ahead and click on it and hit delete. And then if you scroll down just a little bit more, you'll see a table of residuals. Click on that, hit your delete key, and get that out of your way. All right, everything else we're going to need. Go ahead and scroll back all the way to the top and let's take a look. In that first table, we see the basic descriptive statistics for both variables, GPA and study hours per week. In the next table, we see our correlational analysis. In those first two rows, SPSS is computing a Pearson correlation coefficient. Now, you'll see right here there's a row for the GPA variable and a row for the study hours per week variable. And then there's also a column for the GPA variable and a column for study hours per week. So if I want to see the correlation between GPA and study hours per week, I want to come to this cell right here that shows the intersection of those two variables. And the correlation coefficient equals 0.888. That's a pretty strong correlation coefficient. Remember, correlation coefficients range between -1 and 1. And as correlation coefficients approach -1 or 1, they're very strong. And 0.888 is pretty close to 1. So that is a strong positive correlation between these two variables. So I can see in general, as students report more studying per week, they're also reporting higher GPAs. Students who report studying fewer hours per week are also reporting lower GPAs. You can see that this table has some redundancy in it. So for example, this cell right here shows the exact same thing. It's the correlation between study hours per week and college GPA. And then right up here on this small diagonal that you see right here, we see the correlation between GPA and GPA, and right here the correlation between study hours per week and study hours per week. That's not really important information. That's the correlation of one variable with itself, so the correlation equals 1. On that diagonal, you will always see correlations of 1. And that's not anything impressive, it's just simply the correlation of one variable with itself. So long story short, I want to focus on this part of the table right here. That's showing me the correlation between my predictor variable and my criterion variable. All right, now let's move down in that table just a little bit and find out if that correlational analysis is statistically significant. Right here, I see the significance level for the correlation between GPA and study hours per week. And you see it says 0.000. And remember, that's the exact probability. That's the p-value. If that value is less than 5%, we have a statistically significant result. Now, it only shows 0.000 because the table only shows out to 3 decimal places. But when I double click on that table like I did and I hover on that cell, SPSS will show me in that little balloon the actual p-value out many more than 3 decimal places. So that is obviously statistically significant at the 0.05 level because 0% is less than 5%. 0.00 is less than 0.05. Now, that said, there's an important caveat here. For whatever reason, and I don't really like this fact, but you'll see in this table what is reported is the one-tailed significance level. We actually, according to the instructions, want to do a two-tailed test on this correlation coefficient. You might recall it takes less evidence to find statistically significant results with a one-tailed test. So theoretically speaking, it's possible to have statistically significant results for a one-tailed test, but not statistically significant results when that same correlation coefficient is tested for a two-tailed test. Now, in this case, my correlation coefficient is so large, 0.888, that it is statistically significant at the 0.05 level, whether you do a two-tailed test or a one-tailed test. Part of the instructions ask you to look up the critical value for that two-tailed test. So you should be able to compare your obtained correlation coefficient, in this case mine is 0.88, compare that to the critical value that you see in the table, and then find out if you have a statistically significant correlation at the 0.05 level for a two-tailed test. As I mentioned, my correlation coefficient, 0.888, is statistically significant at the 0.05 level for a one-tailed test or for a two-tailed test. All right, let's move down a little bit And let's look at some of those analyses regarding regression. This little table actually has some really important information. It shows me the variables that have been entered into the regression equation. Some students confuse their predictor variable and their criterion variable, and this table will show me if that's the case. Right here it shows me study hours per week. That is the predictor variable. And then it shows right here the dependent variable, which is the criterion variable, college GPA. So in this case, I know that I set that up correctly. So include that table in your research report. Let's scroll down just a little bit more and look at this table that's labeled Model Summary. The first thing you'll see in this table is R, and that is a multiple R. Sometimes we do what's known as multiple regression with multiple or many predictor variables. What we just did was a simple regression with just one predictor variable. So this R value that you see, in this case 0.888, should simply equal the R value that you saw in the correlation table above. And in this case, it does. At this point, what I'm more interested in is this next column right here, and it is labeled R squared. And you might remember that R squared is a measurement of the effect size. And it's very easy to compute. We simply take that R value, 0.888, and we square it. Let's go ahead and verify that. Let's take 0.888 and let's click on x squared. That equals 0.789 approximately. So we're on the right track. In this case, that tells me that about 79% of the variability in college GPA can be explained by study hours. Remember, there are many different measurements of effect size, and adjusted R square is another one. Adjusted R square is adjusted based on the number of predictors in a regression model. We're not using that in this particular course. Another important thing in this table is in this last column right here. That's the standard error of the estimate. According to the instructions, we need to report that in our research report. The standard error of the estimate essentially tells us on average how far off our estimated predicted values are from the actual values that we collected data on. So what we're trying to find out is when we predict a student's GPA from knowing how many hours they study, how far off are those predictions that were made by this regression model? In this case, we're trying to predict people's GPAs, and the standard error of the estimate equals about 0.37. So on average, our predicted GPAs are off from the actual college GPAs by about 0.37 of a grade point. So that's about a third of a grade, about a third of a grade level. As I look at that standard error value, I think that's actually pretty good. Remember, we had a strong correlation between these two variables, so we would assume that one variable can predict the other reasonably well. And in this case, it does reasonably well. Because remember what we're trying to do. I'm trying to predict a person's GPA just by knowing how many hours they study per week. And if I'm able to do that within about a third of a grade level, that's pretty darn good. Let's go ahead and scroll down just a little bit more and look at this last table. This is the table of regression coefficients. From this table, we should be able to create our regression equation. Remember, the basic regression equation is that predicted y equals bx plus a. In other words, our predicted grade point should equal that b weight multiplied by the number of hours that a student studies, and then we add a constant value. So those regression weights that we need, the slope and the y-intercept, should be in this table, and they are. Right here, this is labeled study hours per week, and right there we see that slope. We see the b value, 0.113. We will include that in our regression equation. And then right above it is that y-intercept. People often call that the constant value, and in this case that equals 1.349. So in this case, our full regression equation would be predicted y equals 0.113x plus 1.349. So, in other words, we can use that equation to predict a student's college GPA. I can predict that GPA by taking 0.113, multiplying by the number of hours that they study, and then taking that value and adding 1.349. That will give me that student's predicted college GPA. Here we are back at the instructions. And I just wanted to remind you that for section 7b, we need to use our regression equation to compute the predicted y values for two values of x. Now that we have our regression equation, we can do that very easily. In a minute, we will use a calculator to compute those predicted values. But before we do, I wanted to show you what your SPSS data set looks like right now. You might recall that when we ran that regression analysis, we asked SPSS to save the predicted values. It's those predicted values that we need to compute right now. We already have them computed. So we're going to be able to check the values that we compute with the calculator with the values that SPSS computes for us automatically. And you'll see that you have a new column right here. PRE just stands for predicted. So in this case, it's showing me predicted values for college GPA based on the number of study hours for each student. So the first example that we're going to go through by hand using the calculator will be based on a student with 5 study hours per week. Let's see if we can come close to this predicted value that SPSS computed automatically. All right, let's follow our regression equation. So I'm going to take 0.113, that is our B weight or our slope value. Let's multiply that by 5 study hours per week. So I'm going to multiply by 5. That equals 0.565. I'm just going to leave that in my calculator, and now I need to add that y-intercept, that constant value, which is 1.349. That equals about 1.92. Let's go back to SPSS and see what it computed for its predicted value. Here we are back at our data file. This student studies 5 hours per week, and SPSS predicted that this student has a college GPA of 1.91. So we are definitely on the right track. Remember, there's just a little bit of rounding error. We, by hand, usually go out just about 2 decimal places. SPSS is able to take it many decimal places further. Let's go ahead and compute one more by hand. Let's do it for this student right here, who studies 20 hours per week. So again, we need to use our regression equation. So it starts with 0.113, that is our slope, that is our B weight, and we're going to multiply that by the number of hours that the student studies. In this case, we're talking about 20 hours. That equals about 2.26. I'm going to leave that in my calculator, and now I'm going to add that constant value. I'm going to add that y-intercept, which in this case is 1.349. So we would predict that a student who studies 20 hours per week would have a GPA of about 3.61. Let's go ahead and compare that to the value that SPSS computed automatically. Using our calculator, we found a value of 3.61. SPSS computed a value of 3.599, so we are definitely on the right track. Just a little bit of rounding error in there. Let me point out just a couple more things real quickly while we're looking at this table. We can take these B weights, these slope values, and standardize them. When we have a simple regression with just one predictor variable, like we do right here, that value right here, you can see the column is labeled standardized coefficients beta. That value will always equal the correlation coefficient value. In other words, that value will equal the R value that we computed previously, 0.888. So that should look familiar to you. All right, let's look back at our instructions and see what else we need to do. I think we're almost done. In addition to computing those 2 predicted values in Section 7, Section 7 also says, using SPSS, create a scatter plot. Be sure to put your predictor variable on the x-axis and your criterion variable on the y-axis. Let me show you how to do that. Here we are back at our data file. Normally when we run an analysis, we find almost everything that we need in the Analyze menu. This time though, we're going to go to the Graphs menu. And if you come down here just a little bit, you'll see an option for Regression Variable Plots. That's what we want. So go ahead and click on that, Regression Variable Plots. When we create this scatter plot, we have to make sure that our predictor variable, which in this case is study hours per week, is on the x-axis. And remember, our x-axis is the horizontal axis. We have to make sure that our criterion variable, which is college GPA, is on the y-axis. And the y-axis is the vertical axis. Let's take a minute to look at the available options because some of them might be helpful. If you want to include a title for your scatter plot, you can do that right there where it says chart title. But what we really want to do is include the regression line in that scatter plot. So this says scatter plot fit lines. And remember, we are doing linear regression. We are trying to find a best fitting straight line for our data. So click where it says linear. I also recommend that you take away the check mark where it says bordered box plots for the scatter plots. And that's because I feel that those box plots just kind of get in the way of the scatter plot. I don't want them on my scatter plot, so I take that check mark away. All right, after you do that, go ahead and click Continue. Now I think we're ready to run that analysis, so go ahead and click OK. As usual, our output window opens up and shows us the results of our analysis. Right here, I see the SPSS code that was used to create the scatter plot. I don't need that right now. It's in my way. So I highlight it, I click on it, and then I delete it. And then another thing that I see right here is a legend, a chart legend for the chart that's below. And really, it doesn't have any important information that I don't know already. So I'm going to click on that and delete that as well. And then what I'm left with is this scatter plot. And that's exactly what I need. And here we can see our predictor variable, study hours per week, is on our x-axis. And our criterion variable, GPA, is on our y-axis. And we can see right here, this is the regression line. SPSS is telling us that we should predict various values of GPA based on various values of study hours per week. Now, I'm going to double click on this graph so that we can edit it. And that's because I'm a little bit of a neat freak and I like things to look a particular way. So there are a couple things that I want to change. One thing that I don't like is that SPSS automatically takes this variable, GPA, and it thinks the lowest value that I want to see is somewhere right along 1.5. But I want to see that entire scale that reaches all the way down to 0. So in other words, I want to format that y-axis. And do you see right up here, there's a y and there's an x. If I want to select the y-axis and then format it, all I need to do is click that. So I click on that and I can see that automatically SPSS will find a minimum value of 1.5. And I don't want that. I don't want it to do that automatically. So I'm going to make that a 0. I want it to show GPA all the way down to 0. Now look at what happens when I click apply. You're going to see that that axis will change instantly. And there it is. Now I'm going to close that window. So now I get to see the entire scale. It didn't change anything about the slope of the line. It just changed the way that the graph is displayed. There's just one more thing that I want to fix. You can see right here on the x-axis, there's a little bit of a buffer zone that SPSS builds in between the 0 point and the origin, which is the intersection between the x and the y axes. I want to get rid of that. So I'm going to click on the x-axis, and then right down here where it says lower margin, I'm going to put that to 0% and then click apply. Watch what happens when I click apply. We should see that that 0 moves all the way as far as it can to the left. And it just did. So now I feel I have the most accurate visual representation of my data and my regression line. So I'm going to go ahead and I'm going to close that editor. Let's take one more quick look at our instructions. For section 4, we computed our correlational analysis. For section 5, we computed our regression analysis. We found the slope, we found the y-intercept, we found the standard error of the estimate, and we wrote out our complete regression equation. For step 6, we found our effect size, which was r squared, and we discussed that. And then in step 7, we also created a scatter plot. We also verified a few points on that scatter plot, and we also plotted the regression line. So I think we've done everything that we need to do with SPSS. Take some time to look at the rubric to make sure that you cover everything that you need to cover to maximize your points on this report. It's always smart to look at that rubric to find out exactly how you're going to be graded. The last thing I want to do before ending this video is just remind you how to take those values from SPSS and copy them over into your research report. Remember, there are 2 good methods. The easiest, most straightforward method is just to right-click on a table and then select Copy As, and then click on Image, and then go into your Word file and then paste it in. You can paste it in by hitting Paste, or you can paste it in by hitting Control-V on your keyboard. And remember, these are then pasted in as images, so it's very easy to resize them and to move them around. You might recall there's another easy option that you can use that sometimes works better for some of you, depending on the type of computer you're using, and that's using the snip tool. So on a Windows computer, I like to hit the Windows key, and then I just start typing in snip, and then I can find real easily my snip and sketch tool. I click on that. When that opens up, I just tell it that I want a new snip, and at this point my screen will darken, and I'll be able to use my cursor to select the area of that output window that I want to snip. I lift up my mouse key, and now that area was selected. And now I can just copy that. So I can click this right here to copy it, or I can select Control-C on my keyboard, and then I can go into Word and paste it in just like normal. So for example, I can just click on Paste, or like I showed you before, I can click on Control-V to paste it in that way as well. So there are lots of ways to get your results into your research report. All right, I think we've covered everything. I hope that this has been helpful. If you have any questions about anything, just let me know. In the meantime, be safe.